Now we're going to talk about the discriminant. The discriminant is part of the quadratic formula. It's the part of the formula that goes underneath the radical sign. And let's see why that's important. Let's look at the first equation that we solved using the quadratic equation. I'm sorry, the quadratic formula. And if you want to look at it, it's 8.3.1 in YouTube in the series that we've just published. That's the equation that we're trying to solve. And we got an answer that was x equals the set minus 2, 4. We weren't too surprised at the time when we got two solutions, because when we solved quadratics in the past, by factoring, we usually got two solutions. When we solved quadratics in the past using the square root property, we usually got two solutions. And when we solved quadratics in the past using the completing the square method, we usually got two solutions. But now, because we have the formula, the quadratic formula, we can explain why we got two solutions. And the answer, of course, is in this particular instance. We look at this particular instance, we discover that the reason is hidden in this radical. Plus or minus the square root of 4. Not the plus or minus square root of 2. Plus or minus the square root of 4. Of course, 4 is a perfect square. So since we have plus or minus square root of 4, that's plus or minus 2. That means that our solution is going to be a rational number. Why? Well, that means because 4 is a perfect square, this is going to be a rational number added to a rational number, which is going to provide us with a rational number. When we divide by a rational number, we get a rational number. Now, suppose it wasn't rational. Suppose we were talking about, I don't know, plus or minus square root of 8. Well, that doesn't become a rational number. That stays irrational. Plus or minus. And it's going to be 2 times the square root of 2. Square root of 2 is an important number. It's called the Pythagorean number because back in the time of Pythagoras, it was shown to be irrational. In other words, there was no way you could ever express the square root of 2 as the ratio of two integers. So since that's irrational, if we don't have a perfect solution, then we're going to get two irrational numbers. Of course, the assumption is that the square root is positive. Otherwise, something else happens. But let's get on. Let's move on. Let's look at the second solution. The second solution that we did that used the quadratic was a solution of this equation. And it was the video 8.3.2. In this case, x was a single solution. It was minus 2/3. And of course, the question, why is it minus 2/3, is answered right here. And specifically, we hone in on the radical. Plus or minus the square root of 0. Well, that equals plus or minus 0. 0 is an important number, perhaps one of the two most important numbers in algebra, because a plus 0 equals 0. It's such an important number, it has its own name. It's called the additive identity. Don't worry, this won't show up on a test. It's the additive identity because when I add 0 to itself, I get itself. I get this is identical. Well, this should be an A. Sorry. Similarly, if I subtract it from A, I get A. So it does not affect whatever it's added to or subtracted to. So since this is now a 0, it goes away, and I'm left with a rational number. So in this case, if what appears in the radical sign is 0, then I get one rational solution. Alright, let's move along to the third. And in the third one, Alright, that's now, let's change the color again, just make this more colorful. 8.3.2. We solved this equation, and we got a complex set of numbers as a solution. In fact, we got complex conjugates. 4 plus or minus square root of 3i. It's this I that makes this a complex number, this imaginary number. And why does that happen? Well, again, we look here, and that's x equals. And basically, this is minus 12 over 2. Let's focus in on this guy right here. So we have plus or minus the square root of minus 12. Well, that's plus or minus the square root of 12i, which is plus or minus 2, 2 times the square root of 3i. And that got canceled somewhere along the way. In any case, because this is negative, all right, we end up with a complex number. And two complex numbers because we have the plus or minus. So let's go back and let's look at the discriminant, this thing right here. Before we do that, let's clean up this mess. All right, as I was saying, the discriminant is equal to b squared minus 4ac. It's the thing that's inside, the expression that's inside the radical. And it determines by itself what type of equation we have. So in the first case, if the discriminant b squared minus 4ac is greater than 0, then you get two real solutions. If b squared minus 4ac is greater than 0 and b squared minus 4ac equals a perfect square, then you get two rational solutions. And then last but not least, if the discriminant b squared minus 4ac is greater than 0 and it, meaning the discriminant, is not a perfect square, then you get two irrational solutions. Oops, that's an if here. If, you get a whole bunch of conditions here. If the discriminant b squared minus 4ac equals 0, then one rational solution. Now I have to realize in this case that's because we've restricted a, b, and c to rational numbers. We could actually do a quadratic equation with complex numbers, but that's much more advanced than this class, so don't worry about it. So for our intents and purposes, we're going to get only one solution, and in our case it's going to be rational. So if the discriminant is 0, it's one rational solution. And last but not least, if the discriminant b squared minus 4ac is less than 0, then we get two complex solutions. Now, next time, we are going to look at a couple of applications of the quadratic equations. In other words, we're going to solve a word problem with quadratic equation. Till then, bye for now.